Assalamualaikum warahmatullahi wabarakatuh and a very good morning. In this video, we are going to learn about the hypothesis test for two populations. So the first one, we will identify how to find the hypothesis test involving differences of two population means, involving differences of two proportions for large sample given the first sample size is greater than equals to 30 and the second sample size is greater than and equals to 30. And the last one is the hypothesis test involving the ratio of two population variances. So when we compare two populations, we need two samples, one for each. So this is the first population where we have to find the sample from this first population. And then we have another population, and from the second population, we also need sample from the population 2 and compare with this both sample. So the sample selected from the two populations must be random and independent. So what does it mean by independent? So two samples are called independent sample if the sample selected from one of the population has no effect on the samples selected from the other populations. So now we move to the hypothesis test involving differences of two populations mean. Given the first population mean is mu1 minus with mu2. So the first step for the hypothesis test is to make inferences about a population mean that is assumed to be distributed normally. So the null hypothesis is given as since our cases is involve differences of two population means, so the null hypothesis becomes the difference of two population means given that mu1 minus mu2 equals to the value of the mean, which is given as mu naught. And not the alternative hypothesis where this is our claim. So the first case for the alternative case or for the alternative hypothesis is the difference of two populations means greater than mu naught. So we will reject H naught when the Z test is greater than the critical value. And then for the cases of the difference of two populations mean less than the mu naught, we will reject H naught when the Z test is less than negative critical value. And the last one, if the cases of two populations means is not equals to the mean naught, we will reject H naught when the modulus of Z test is greater than the critical value given that it is Z alpha over 2. So the cases, the reject H naught is just the same like the one population. But what make it different is just the symbol here, okay? Since it involves the differences of two populations means, so we write on the left side is mu1 minus mu2. And then we have to identify the test statistic. So for the hypothesis test involving two populations means can be categorized as these three cases. Case 1, if the population variances are known and both N1 and N2 are samples of any size. The next case is for the population variance are unknown. Okay, so for the first case, the population variance are known. The second case is where the population variances are unknown. However, there are two cases for this population variance are unknown. The first case is if the sample size are large, given the sample size of both are larger than or equals to 30 for N1 and for N2 is also greater than equals to 30. And the third case, if the sample size of N1 and N2 are small, given that N1 is less than 30, N2 is less than 30. So in these two cases, we have two conditions. The first one is the population variance are assumed to be equal, and the second one is the population variance are assumed to be not equal. So in case 2, there are two conditions: equal population variance, not equal population variance, and also in case 3, there are two cases where the population variance are equal and the population variance are assumed to be not equal. Okay, now let's go through the first case. If the population variances are known and both N1 and N2 are sample of any size, then the test statistics that will be used is z-test, given it is equals to the mean, the sample mean from the sample 1 minus with the sample mean from sample 2 minus with mu naught over the square root of the population variance for 1 over N1 plus with the population variance 2 over N2. Now let's go through the example 1 for the first case. So given the mean lifetime of 30 bulbs produced by company A is 500 and the mean lifetime of 35 bulbs produced by company B is 492 hours. So here, given that we have bulbs produced by two companies, given the first company is from company A and from the second company is from company B. And here we have the situation given that the mean lifetime of 30 bulbs produced by company A is 500. So here, this statement is the mean from the sample. Okay, so given mean from the sample is given as X bar. Okay, from company A is equals to 500 and 30 bulbs refers to the number of sample from company A. So here NA is equals to 30. And then the mean lifetime of 35 bulbs. So 35 is the number of sample taken from the company B. So NB would be 35. And then the mean of the 35 bulbs produced by company B. So here would be X bar equals to 492. Okay, now we have another information. If the standard deviation of all bulbs, so this refers to the population standard deviation. So given it is produced by company A is 10 hours, so sigma A equals to 10, and the standard deviation of all bulbs produced by company B is 15 hours. So now we want to test at 1% significant level that the mean lifetime of bulbs produced by company A is better than that of company B. So alpha would be equals to 0.01. Alright, so now is that we have all this information. Now we need to build our hypothesis. So they make claim that the mean lifetime of bulb produced by company A is better than that of company B. So to make our null hypothesis, so we can make the hypothesis for the null hypothesis is the mean lifetime of bulb produced by company A should be equals to from the company B. So mu A equals to mu B, and the claim given is that the mean by company A is better than, okay, should be greater than company B. So if we rewrite this hypothesis, you will get mu A minus mu B equals to 0. And for the alternative hypothesis, it will be mu A minus mu B greater than 0. So here 0 is defined as our mu naught. Okay, so how can I make this hypothesis? It's just I bring this mu B to the left hand side. So mu A minus mu B equals to 0, and mu A minus mu B greater than 0. So we have made this hypothesis. The second part is that we have to identify the z-test, okay, the test statistic. So since this is the case 1, so we use the z-test, where given the formula is the x bar from the first population minus with x bar from the second population minus with mu naught over the square root of the population variance from the first population over NA plus with the variance from the second population over the sample from the second population. So x bar A is given 500 minus 492 minus mu naught is given as 0 over the square root of the population variance from A is 10 square, because y squared, because this is the standard deviation value. Okay, so to find the variance, we just have to square this standard deviation over NA plus the variance from B over 35, which is equals to 2.56. So now let's identify whether we have to reject or accept as note. Okay, by identify the value of the critical value. Now we want to find the critical value. So given that the significant level is alpha is 0.01. So we want to find the critical value of Z alpha given that this is Z 0.01. So Z 0.01 tells us that we want to find the Z score that has 0.01 area to the right. So this will be our area, because given that this standard normal distribution given in the middle part here would be 0. Okay, so the total area under the curve for the whole curve would be equals to 1. So for the 0.01, which means that it is the area to the right, so it will be a very small area, which given that this is 0.01 area. Okay, so the left of this area, where this one, will be 1 minus 0.01, which is 0.99. So this area is where we need to find in this cumulative standard normal distribution table. So given this is the area on the left of this, which is 0.99, so you just go through the value of 0.99. So you can see this is the closest value, which is given as 0.9901. Okay, so now we can find the Z score of this Z0.01, given that this is 2.33. So that's how we find the Z score or the critical value for Z0.01. So it applies for all the value of the significance level. Okay, let's say you want to find alpha equals to 0.05. So the area would be on the right is 0.05. So the left area would be 0.95. So you have to find the value of 0.95 in this table. So given the closest value would be this one, 1. Okay, between these two. Okay, it can be 1.65. Okay, so that is how we find the Z score. Proceed with this problem. So given that from the Z-test where we get is from the formula is equals to 2.56 and Z0.01 is given as 2.33. So this is our Z0.01, 2.33. So the rejection area would be here, which means that if the Z-test greater than the critical value, okay, we will reject hash node. So from this Z-test, given our Z-test is 2.56, which means that this is the value of Z-test. So you can see since our Z-test is greater than Z0.01, so we have to reject H node, which means that the data provides sufficient evidence that the mean lifetime of bulbs from company A is better than that of company B. Now we move to the next condition given the population variance are unknown. Okay, so for the case 2, if the sample size of N1 and N2 are large, given N1 is greater than equals to 30 and N2 is greater than equals to 30, and for this condition, the population variance are assumed to be equal. So the first population variance are equal to the second population variance. So for this condition, the test statistics to be used is Z-test equals to the sample mean from the first population minus with the sample mean from second population minus with mu naught over SP times with the square root of 1 over N1 plus 1 over N2, where SP is the pool standard deviation. So the formula for the pool standard deviation is given as the square root of N1 minus 1 times with the sample standard deviation from first population plus with N2 minus 1 times with variance from the second population, sample from the second population over N1 plus N2 minus 2. So this is the sample sample variance, and this is also sample standard deviation. Alright, so now let's go through the example for this case. Given an Arabic placement test was given to two classes of 40 and 50 students respectively. So as we go through, we just write down all the important things from all the important information from the situation. So here we have from these two classes. So the first classes, the number of sample is 40. So we have two classes, 1 and 2. Given from class 1, the number of sample taken is 40 students. And from the second class would be equals to 50. In the first class, the mean grade was 74. So this is the mean that is from sample. Okay, it's not from the population. So here we have x bar equals to 74 from the first class, and the standard deviation is also from the sample. So S1 equals to 8, while in the second class the mean grade was 78 with a standard deviation of 2. So S2 would be equals to 7. So now, is there a significant difference between the performance of the two classes at 5% significance level? So given that we have to make assumption that the two population variances are equal. So this is the case 2, okay, with condition 1, okay, given that the population variances are equal. So given alpha is equals to 0.05. So now what we need to do is we have to define the hypothesis. So the H note will be the mean of the two classes, the mean of the first class equals to the mean from the class 2, and then we make a claim that the difference, is there any difference between the performance of the two classes? So the mean of from the two classes, is it not equals to from the second class? So this one can be rewritten as mu1 minus mu2 equals to 0. Meanwhile, for the alternative hypothesis, it will be not equals to 0. So our mu naught will be equals to 0. So now, since it is the condition given that the population variances are equal, so we use the z-test, where z-test equals to x bar 1 minus x bar 2 minus mu naught over SP square root of 1 over n1 plus 1 over n2. So here first let's find the value of SP, which is equals to the square root of n1. So here is our n1, 40 minus 1, and then the variance from the class 1 is 8 square over then plus with n2, and the variance from class 2 square over 40 plus 50 minus 2, 7.46. So here we can find our z-test. Our x bar is given as 74 minus with 78 minus mu naught is 0, and SP is 7.46 times with 1 over 40 plus 1 over 50. This equals to negative 2.53. So this is the value of z-test. So now let's identify our z alpha over 2. Why is we have to find Z alpha over 2? Is because this alternative hypothesis that the claim here is not equals. So we have to divide the significance level, divide by 2. So it will be Z alpha is 0.05 over 2, which is Z 0.025. So from the table, given that Z 0.025, here is the area on the right. So given this is 0.025. So from the table, what we need to find is 1 minus 0.025. Given this is equals to 0.975. So from the table, you just have to find the value of 0.975, and you can see the value of 0.975 is 1.96. So now we know that the critical value of this Z 0.025 is equals to 0.975. Since we, sorry, it's not 0.975, it is 1.96. Okay, 1.96. So this is the value of the 0.975. So same goes for the left side. Okay, why we have to find for both sides? Because the alternative hypothesis involve the not equal sign. So we have to divide the alpha to 2. So this would be for negative 0, Z 0.025. So the value for this critical value is equals to negative 1.96. And from the previous solution that we have Z test is equals to negative 2.53, meaning that negative 2.53 lies in this area, which means that it is in the rejection area. So since our Z test, which is equals to negative 2.53, is less than negative Z 0.025, which is equals to negative 1.96, so we can reject H note. So which means that the data provides sufficient evidence that there is a significance difference between the performance of the two classes at 5% significance level. Now is the next case where the population variance are unknown and the sample size of N1 and N2 are large. However, the population variance from the first population and the second population are assumed to be not equal. Okay, the previous case is that the population variance are assumed to be equal. So for this case is that it is not equal. So the test statistic to be used is using the Z test equals to the sample mean from first population minus with the sample mean from the second population minus with mu naught over the square root of the variance from the sample 1 over N1 plus the variance from 2 over N2. Now pause the video and identify all the information things inside this situation. Suppose that we want to investigate whether men's average earning exceeds women's average earning more than 20 ringgit per week in a certain workplace. And then we have a sample of 60 men earn an average of 294. So this is a sample from men. Given that our NM is equals to 60 and the average, which is X bar from the men, is 294 ringgit per week. And the standard deviation is equals to 16. While a sample of 60 women is also equals to 60, earn an average of 265 ringgit per week, with a standard deviation of 18 ringgit. So what can we conclude at a 1% significance level? So alpha is given as 0.01. Assume the two population variances are not equal. Okay, so from this situation, you can see there is no population variance. So this situation falls under the population variance are unknown. Okay, and also the two population variance are assumed are not equal. So now we have the list of all the important information from the situation. So now what we can do is we identify what are the hypotheses that can be written. For this part, we want to investigate whether men's average earning exceeds women's average earning more than 20 ringgit per week in a certain workplace. So here we can write, this is our claim. Okay, we want to investigate the average men more than average woman, okay, which is more than 20 ringgit. So here we can write our alternative hypothesis given that mean from men, okay, exceeds the mean from women is exceed RM 20 ringgit. So for our null hypothesis, it will be the difference of two means is equals to 20 ringgit. Okay, so this is our hypothesis. Okay, so using this information, and also we know that this is the case for the population or for the sample that is greater than 30, and also the cases of populations are unknown, but we assume that the population variances are not equal, so we will use z-test. Okay, so given that the z-test is equals to x bar 1 minus x bar 2, so here given as men and women minus with mu naught over S1 is from men over N1 plus variance from woman and woman. Okay, so this is our formula for z-test. So this, just I will write this one is the variance are not equal. So men are not equal to the variance from women. So our z-test would be equals to x bar 295 minus with 265 minus mu naught. Mu naught is obtained from this value. Okay, mu naught is 20 over the square root of 16 square over n, which is 60, plus 18 square over 60. 2.895. So this is the value of our z-test. So now we want to identify the critical value. Here we have our z alpha is z 0.01. So from the table, our value of 0.01 is equals to 2.33. So we will reject edge node if the z-test is greater than 2.33. So you can see our z-test is 2.895, which lies here. So which means that since z-test is equals to 2.895 is greater than the critical value, so we reject H node. So we can conclude that the data provides sufficient evidence that the average earning per week for men exceeds, okay, so just rewrite this, exceeds woman average earning more than 20 ringgit per week, okay, at 1% significant level. So now we move to the next case where still the population variance are unknown. However, the sample size of N1 and N2 are small, given that the small is considered if the value of the sample size is less than 30. Okay, so N1 would be less than 30 and N2 would be less than 30. And the condition for the first case is the population are assumed to be equal. The population variance are assumed to be equal. So for this case, okay, given that the population variance are assumed to be equal, the test statistic to be used is t-test. Given the formula is the mean from the sample size from first population minus with the sample mean from second population minus with mu naught over SP, which is the pool standard deviation, times with the square root of 1 over N1 plus 1 over N2. Given this is the formula for the pool standard deviation, and given V, where V is the degree of freedom, is given as N1 plus N2 minus 2. So this will be used when we want to find the critical value. So now let's try the example for this case. So you can pause this video and try to solve the question. And before that, identify what are the important values involved in this situation. So an experiment is conducted to test the breaking strength of two types of metal rod. A sample of 12-meter long metal rods has a mean breaking strength of 80 kg and a standard deviation of 4 kg. So this is from the first population. Okay, and then the second population, so we have sample from 12 meter. A sample of 12 meter has and then for the mean is 80 kgs And then the standard deviation is 4 kgs. Okay, and then for the second sample of 12 meters, so our N2 would be 12. Mean for sample population 2 would be 76 and the standard deviation is 5. Test a 5% significance, so this is our alpha 0.05, that the mean breaking strength of the two types of metal rods is the same. Okay, and assume that the two population variance are equal. So here you can see that the sample size is less than 30. So this fall under the case where the sample size are small. Okay, and there is no value of the population variance given. Okay, and also we have the assumption that the two population variance are equal. So here is sigma square from population 1 equals to the population variance 2. Next is we need to identify the hypothesis of this problem. So the null hypothesis would be the mean of two types is the same. Or is it not the same? Or we can also write this as mu1 minus mu2 equals 0. Or mu1 minus mu2 not equals to 0. So now we have identified the hypothesis. Next is to find the test. So since this is a small sample size and the population of the variants are equal, so we will use the t-test, which is equals to and then first let's identify the value of SP. So our N1 is 12 minus 1. The variance from the sample would be 4 square and then the variance will be 5 square over N1 plus N2 minus 2. Is equals to 4.53. So 80 minus 76 minus mu naught is obtained from this value in the hypothesis, minus 0 over 4.53, 1 over 12 plus 1 over 12, which is equals to 2.16. So this is our t-test value. So now we need to identify the critical value. So since the alternative hypothesis involve no equal sign, which means that we will divide this into 2. So it will be T alpha over 2 for negative, and then the degree of freedom V, and this one would be T alpha over 2 V. So T alpha over 2 given alpha is equals to 0.05. So alpha over 2 would be 0.025. And V is given from the formula, which is equals to N1 plus N2 minus 2. So here would be 12 plus 12 minus 2, which is equals to 22. So this is our degree of freedom. So using the table, you will get the value of this, which is equals to 2.074. So now since T 0.025 is equals to 2.074 and our T test is equals to 2.16, which lies here, which is more than the critical value, so we can say that we have to reject H naught. So since T test greater than the critical value 2.074, we reject H naught. So we can conclude that the data provides sufficient evidence that the mean breaking strength for the two types of metal rods is significantly different at 5% significance level. Now we move to the last case where for the population variance are unknown and the sample size of N1 and N2 are small, given N1 less than 30, N2 is less than 30, and the population variance are assumed to be not equal. So for this case that the population variance are not equal, the test statistic to be used is t-test. Given that it is equivalent to the sample mean from population 1 minus with sample mean from population 2 minus mu naught over the square root of the variance from the sample variance over N1 plus sample variance from population 2 over N2. With the degree of freedom formula is given as this. So you can pause this video and try to identify all the important values needed in this situation and try to solve using the previous formula. So I just assume Johor as 1 and Kedah as 2. So from this table, you should get all this information where the sample size for Johor is equals to 9, the mean is equals to 58, and the standard deviation is equals to 10.44. Meanwhile, for Kedah, the sample size is 6, the mean is 60, and the standard deviation is 8.76. So assume that the two population variants are not equal. We want to test that the mean sales in Johor is less than the mean sales in Kedah at 5% significance level. So we want to test whether this claim should be accepted or rejected. So now is to identify the hypothesis. Given the hypothesis for this case is the mean from Johor should be equals to mean from Kedah. And then the claim should be the mean from Johor is less than mean from Kedah, mean in Kedah. So this one would be, okay, so you also can write it as mu1 minus mu2 equals to 0. Meanwhile, for the alternative hypothesis, it will be mu1 minus mu2 less than 0. So our 0 is our mu naught. Then we have to use the t-test. Okay, given that our t-test is equals to x bar 1 which is 58 minus 60 minus mu naught over the variance from the first population over N1 plus with 8.76 square over 6. And you get negative 0.4. So that is your t-test. Now we have to identify the critical value. So now we want to identify the critical value given alpha is equals to 0.05 and given that our alternative hypothesis is less than, meaning that this critical value should be negative of t, alpha is 0.05 and the degree of freedom is given as p. where V is given as this formula. So now just substitute all the values into this. So you get 10.44 square over 9 plus 8.76 square over 6, and this whole is squared over 10.44 square over 9 over 9 minus 1 is 8, and then 8.76 square over 6, and this whole is squared over 6 minus 1 is 5. And you get 12.15. So we round out to 12. So this one will be negative t 0.0512. So using the table, you should get negative 1.782. So we will recheck H note. If the t-test is less than this critical value, so here is our critical value, is equals to negative 1.782. However, our t-test is negative 0.4, which lies here, which means that we do not reject H naught. Okay, so we can say since our t-test is greater than the critical value, so we accept H naught, which means that the data does not provide sufficient evidence to accept the claim that the mean sales in Johor is less than the mean sales in Kedah at 5% significance level. Okay, so that's all for the hypothesis test involving differences of two populations mean.